All right, this is 6.4, identifying functions. So this takes everything that we've done so far and kind of combines it into one lesson. So let's start with linear. So the equation for linear we know is y equals mx plus b, or we saw the other day, it could also be y equals x. So we've said that this doesn't have an exponent, it just has an x. We're getting pretty good about identifying that equation. I'm going to jump over here to the graph. We're also getting pretty good about identifying the graph of this. What we need to focus on is how do I identify this from a table or a function map? So this says x increases at a constant rate, y increases at a constant rate. So we have to check both. So -3 to 4 is plus 1. -4 to 5 is plus 1. 7 to 10, from -7 to 10, it's going to go down 3. From -10 to 13, it's going to go down 3. So both of these are increasing or decreasing at a constant rate. It's the same. So when you get to a function map, we have to look, if they're straight across, then we can just look at this. If not, then we need to make a table. So an XY table. So -3, -7, -4, 10, -5, -13. So that's increasing, it's down 1 and down 1, which, let's go back over here and change this one. This is actually decreasing by 1 each time. So let's get that one fixed. And this one goes from -7 to positive 10. Oh, I think that's a -10. Look right here. I think that negative sign got covered by the arrow. So let's do that again. -7 to -10 is a decrease of 3. -10 to -13 is a decrease of 3. And it's decreasing by the same amount. So that's how you tell if it's linear. Okay, so let's look at quadratic. By the way, we know how to identify quadratic. The equation has an x squared. We know how to identify the graph of quadratics because it makes the parabola shape. So let's look at the table. Now I do want you to add two numbers at the bottom. So go ahead and put -6 and 39 at the bottom of your table. X increases at a constant rate. So let's check. That's decreasing by 1, decreasing by 1. Good. Now this says the second difference. So that means we're going to start with the first difference. So from 12 to 19, that goes up 7. From 19 to 28, that goes up 9. From 28 to 39, that goes up 11. That's not constant, but this is the first difference. Now we look at the second difference. From 7 to 9 is 2. From 9 to 11 is 2. The second difference is constant. Okay, so we're going to kind of skip the table because you need 4 to do the function map. So that's okay. We'll just skip this one for now. Let's look at exponential. So we talked about this. Exponential has an x as an exponent. Exponential, x, exponent. We also know that what the graph of this looks like. This is exponential growth. So let's look at this table. It says x needs to increase at a constant rate. So that goes up 1. That goes up 1. But y increases by a common factor. This means multiply. So this is times 2. 2 times 8 is 16. 16 times 2 is 32. So this increases by a common factor, which makes it exponential. So the same thing over here. Remember, if your arrows go straight across like this does, you actually don't have to make a table for it. So this is plus 1. So x increases at a constant rate. 8 to 16 times 2. 16 to 32 times 2. Okay, so let's look at absolute value. Okay, well, the absolute value has an absolute value sign. We talked about that in class a couple days ago. We also know that the graph of that looks like a V shape. So let's look at the table. This says x increases at a constant rate. So they all have that in common, that x increases or decreases at a constant rate. So it looks like this one decreases by 1 every time. By the way, add the -6 one at the bottom. Because y increases at a constant rate, but you must have a vertex. Remember, we talked about if you would cover that portion over, it looks linear. So we have to have a vertex in order to understand what's happening. So from this one, it goes from 0 to 1, from 1 to 2, and then from 2 to 1 is a -1, but it's still an increase or a decrease by 1. And this would be your vertex. Okay, so let's look at this one. This one goes from -3 to -4, -4 to -5, from 0 to 1, and 1 back to 0, this being your vertex. So both of those fit the mold. Okay, so let's look at this first example right here. And you know what? I think we might just keep this for class, and we'll look at these in class together the next time, or when we do these notes.